the rest of the sessions in this conference. We will be, so yes, so Adam, would you introduce yourself and tell us a little bit how you are involved in the development and application of AI technologies in the realm of IT operations?
Okay, so hi, I'm Adam. I've been at Google for like 12 years, exactly to the day today. So the first few years I spent working on some high availability billing and the fraud detection systems. And then I sort of moved to working on large scale data analytics and more recently machine learning. So the group that I together with some other leads preside, we are working on machine learning infrastructure for both internal use cases and for Google Cloud. And as always, we are very interested in also making sure that we use our own technologies to automate ourselves out of the job.
Thank you, Adam. Very good points. And let's move on to Matt.
Yeah, I agree with Adam's last point there. And how do we automate ourselves? It's still like a job, but let's say make it a little bit easier with some of the AI that's on the horizon here. Hi, everyone. This is Matt Leighton here. And Fausto, thanks for inviting me to join the panel here. I run all of our hosting platforms across our hybrid cloud environment for our IBM CIO organization. So think of all your mission critical workloads that support how our business runs. And so extremely interested as these technologies become available, what can they tell us that we don't already know about our environment? Especially when you think about it, my experience has been in the infrastructure and operations part of the organization, you have typically people like to stay there. I don't know if it's just they love what they're doing, but they have a lot of background and expertise. And so a lot of times when the tools come on, they don't necessarily tell us something that we haven't already known. But in order to speed up our operations as the business changes more rapidly and application workloads become much more dynamic, I see the potential there for humans coming out of the equation eventually, but it's got to be real, it's got to be valuable, and it's got to tell us something that we don't already know.
Thank you. Thank you. So with that, I thought I would start with an initial question to sort of look at the state of the work today. What I would like to ask both of you is, where do you see at this time big data analytics and machine learning having the biggest impact in IT operations? Do we have any good proof points in some of the areas that have been, that we have listed, from capacity management to managing resources to managing tickets to looking at alerts and mining logs? Let's start again with Adam. How do you see success stories as of today?
I would say the biggest success stories right now is in automating some of the operations or some of the things that people were tweeting manually. I think a few years back, we as a sort of a company, we published a paper of how do we optimize cooling infrastructure in data centers with machine learning. And I see many times that machine learning is like a force multiplier where it can be a bit more intelligent than the typical automation built with the rules. But it's rarely a silver bullet, or it's rarely something magical that will just fundamentally change the way how we operate. So I think I was also previously mentioning to Fausto and Matt, I see the biggest use or the biggest achievements right now of machine learning in the areas where the problems are very well defined, where you can specify some function that the model can optimize, and you can evaluate the model based on the function. And the further we move away from this sort of kind of contain and box problem, the more easy things become. Like, yes, we can have and have some kind of assistive technologies that can tell us like that there are some anomalies, or maybe both in the time series and in sort of values, where sort of looking at metrics, it can tell us that there was some event that happened, or as I think also Fausto pointed out, like you can also look at the anomaly detection in the sort of log domain space, where when someone is trying to debug situation, they can maybe highlight some of the messages that were not typical maybe at this time of a day or are typical to that system before. So I would say, yeah, typically optimization problems. I think I see the biggest use and the biggest sort of rollout already to production, and still a lot of sort of toying around, like how can we actually augment humans so that they make faster decisions or better decisions in actually operating the systems later on.
Thanks, Adam. Matt, what is your take?
Yeah, I have to say I agree with a lot of what Adam said. And unfortunately for me, the interesting problems are the ones that are not really well defined. Like Adam described, we went through and continue to go through work and we automate things. That's not necessarily AI, but looking at basic patterns. And I've seen this before, and I'm just going to, have a script to resolve that so humans don't need to get involved. But for me, it's really where we haven't seen a whole lot of benefit, these complex problems of, again, I characterize it as tell me something I don't know, predict for me when an event's going to happen. And one of the complexities I think that makes it challenging in an environment like my team runs is we're dealing with applications that are decades of years old, that are on legacy architectures and different log files and formats and behave a certain way, again, based on certain time of the quarter, time of the month, all the way to applications that were created today and yesterday with very modern architectures. And so being able to handle a variety of those situations, I think is extremely challenging. So again, like Adam described, I think there's some early indicators where change management, for example, you can start to detect different patterns and assess risk based on historical performance of maybe the team that's conducting the change or the type of application that it's in. And given your tolerance for risk based on a certain time of the month to things like capacity management. I think the real interesting piece, though, for me is going to be when we get into these a little bit amorphous problems where we don't know what's going to happen next or where a disaster could occur and need something to help augment the humans that are doing those tasks and performing the remediations.
Thank you to you both. At this point, I'd like to invite our audience to ask any questions they may have. You can do so by, from the chat. You can type into the chat, or given that we're a small group, you can also pop in on screen or just ask your question. Okay, I'll, while you think about what you'd like to ask our practitioners here, let me continue with my train of thought. So we heard about the current challenge. And yes, I mean, it's true that, while we've been talking about AI ops for a few years now, and there's certainly been some proof points and some, great examples published in the literature, we haven't really seen that mass scale adoption that maybe, the most optimistic among us would have expected. What are your thoughts for why that is? I mean, we've certainly seen many other areas in which AI has made great strides, be it computer vision or natural language processing and others. I think this is maybe happening at a slower pace in this case, and it may have to do with data, is my hunch. But I'll leave it to you to discuss this point. Maybe let's start with Matt first this time. What do you see as the specific challenge?
I think part of it's kind of what Adam touched on is that it is so big. I mean, it's kind of like when you talk about cancer as a disease, but as one single thing, that's kind of like describing AI ops. But really, when you get into it, there's many, many different things that we care about, each with has its own characteristics and problems to solve. So whether that's capacity management, whether that's change management, whether that's incident management, whether that's incident resolution, whether it's triaging the incident. So each one of those is a more specific and well-defined problem. Just tell me what my environment looks like and the impact of performing some operation on the environment. I think that fundamentally is the problem. So like, don't try to sell me on AI for operations management. Like, let's get into a specific problem that we can talk about, something very tactical that we can get done today, where if AI is a part of the solution, great. I think the other aspect is that there's a lot of things that don't necessarily require AI. And if it's faster for me to train a junior engineer off the street and say, hey, look at these 3 things, and here's what you do if you see these 3 things, that's a lot faster for me to do it than waiting for months and years of experimentation. And then I think the third challenge that I would say is the complexity of the environment, especially in heterogeneous environments. I think if your architecture is in your environment is very homogeneous, probably going to see AI for operations management addressing those areas than you are in a decades old, very complex environment that's evolved over the years and kind of keeps getting components added to it, almost like the Winchester house out in California, if you're familiar with like that. Sometimes it feels like that, which I think then exacerbates where you can fit AI into the equation to actually add value to the organizations. So I think those are really the 3 things in my mind that are making it specifically challenging to bring AI into the environment at the scale, like you mentioned.
Yep, very much so. Let's hear from Adam. Do you want to add to the list of challenges?
Oh yeah, I mean, the list just goes on and on. But I agree. I think at some point we should not stop saying about AI for ops as a sort of one single problem. That is, we are going to reach one sort of superhuman model that will solve it once and for all. I think we are at the stage where we should be looking at the specific tasks and see what solutions do we have for that. And for different tasks, I think that the problems are different. So Matt, for instance, mentioned some of the old software. We have less of this problem, for instance, at Google. Actually, at some time we would say that we have a bit of the opposite problem, where many teams will try to push changes to production at least on a weekly basis, if not even more often. And this basically means that the world that you're operating in is very non-stationary. It means that it's constantly changing, and sort of if you train your model on the data that happened like a week ago, the next release will fix some problems, will bring some other, and it's almost going to be useless. And at the same time, and I think something that you folks alluded to is that it's also that the data is very sparse, especially once we get to this sort of higher level interactions. So like, oh, how do you classify some outage, or how do you react to a particular signal? You usually have only sort of countable number of data points. And at the same time, many times they're also not of the highest quality. You mentioned the vision models. Vision models oftentimes, for the examples, have sort of multiple labelers actually classifying the images, and they also don't always agree. Like some people will call it a lion, a cat. The other will just, I don't know, say it's a lion, or maybe some other will say it's a mountain lion. Like depending on the expertise of the labeler, you also have a different level of granularity. So amount of data, the quality of data it's certainly a problem for this sort of higher level applications. One other challenge that I see is that a lot of a world right now is very excited about sort of the deep learning and deep networks. One thing that we are maybe missing with that is that those types of networks are very poor at explainability. Like, yes, there are some technologies that can help to explain some of those decisions, but especially once we go into the operations and not in the sort of sense where the machine model is optimizing some well-defined function and we can sort of verify and test that it's performing well, but it's when it's actually suggesting something like, okay, if you notice this event, do X. It will be very interesting for the model to actually be able to explain it to you, like why did it think that X is the right action, or why did it think it's actually relevant? And especially once we actually try to move beyond the augmentation and maybe self sort of actuation, this is going to be super important for people to actually trust the AI to automatically operate the system. And again, this is more in the sort of the higher level of management of operation, because for things like capacity planning or maybe pre-scaling some of the instances, those are already fairly well verified, and we know those models work. It's just, again, higher level applications will have some trust issues. And this is, I don't want us to always kind of agree with each other, then therefore I'll try to disagree with one thing that Matt said. I think in the end, in the long run, we shouldn't try to feed sort of machines with the human blood. Like, we shouldn't train junior engineers to look at graphs. Those things we should find a way how to train, like either write an automation or maybe use at some point machine learning if this is the only solution. But I also would agree with the principle that the same way as we shouldn't automate the broken process, we should get rid of the broken process. We shouldn't use machine learning for the process that automation can solve, because as the simpler the things, the better, and it's easier to basically understand and debug them later on.
Well, I see. Well, and as you were speaking there, Adam, that got me to think that I think one element that we're missing here is time, because if I bring in a junior engineer or a junior administrator, if they mess up, I accept that's part of their learning or education. I mean, I certainly messed up a couple of times early in my career and had to explain that to my boss. But B, then they actually can explain it to the boss. Where right now it's easier for me to say, hey, Johnny, junior engineer, messed this up to my boss or CIO of IBM, than would be to explain, hey, Fausto here gave me this AI model and I don't know how it worked and it messed everything up. My boss isn't going to be too happy about that. So I think the explainability is very important to that. But I think also the time, because if you think about that junior sysadmin, as they see more happen in the environment and get to know that environment, and whether it's a new employee that has a lot of experience, that's going to be applied and they're going to adapt the way that they approach different types of problem solving. And I don't think, quite frankly, I've seen that we're giving the AI ops solutions that sort of benefit of the doubt. To your point, it's been kind of, hey, we expect this to be general purpose, when I would argue my environment is not general purpose. My environment is kind of built for a very specific purpose to run my organization's business, and there has specific attributes and characteristics that, yes, someone with some general expertise coming in off the out of the street can get up to speed more quickly than without expertise, but it's still going to take them time to learn about the characteristics of my environment and how it behaves.
Those are excellent points. I was so just to follow up on something Adam said before, you mentioned sparse data, which actually surprised me, because normally we deal with a deluge of data. I mean, it's even, too much. One of the reasons that, again, AI ops, to use this label in the generic sense of the things we're discussing, one of the things that it's supposed to help us deal with is exactly the mass of data that seems to grow at levels that are no longer actionable by humans. But I don't know how much that is true. I mean, we've been good at, building filters and building, rule-based systems that make some sense of that data. And of course, now we would like AI systems to be able to maybe automatically find out, filter thresholds and, tweak other parameters so that that data becomes more consumable by the human eye and thought. Can you maybe explore a little bit that topic of data? I mean, let's start with Adam. But so, as you mentioned, right, like in vision, yes, progress was made when we started having sort of a large database of human labeled pictures. Is there something similar in this field, and is there maybe a community effort that's needed to create a good database to train our models on?
I think you're touching on a few important things. Like, yes, first of all, I think there's probably a lot of data, but it's very siloed. And especially once you look at the logs, it's very hard to make sure that that doesn't contain any kind of confidential information, especially to the customers. And companies, I don't think, are very willing to kind of take the risk of sharing this data without the proper anonymization. Well, luckily enough, I guess we have some models that can detect some identify information. So maybe you could use that to scrape the data. But so siloing the data is being one. When I was referring to the size of the data, this is, I would say, especially for these higher level operations. And it's not only about the data, it's about the labels. So if you were to train some unsupervised or sort of self-supervised model, like this requires a lot of data, like really a lot. And otherwise you need to have a good quality label. So it's not that you don't have data points. You don't have data points with the right labels. You don't have that many points with humans telling you, okay, there's actually an anomaly here. There's something wrong. Like we should mark this, and the model should be able to detect that. And then the other part, as I said, I think there is something about the sort of this constantly changing environment in the vision models. And again, vision like object detection is a well-defined problem. You have usually you come with some sort of dictionary of the labels that you're going to apply, and the model is not going to spit out the label that it actually never seen before. So if your data set never had I don't know, the Nikon cameras, or maybe the other cameras, like only seen Sony camera, it's not going to somehow synthesize that, okay, now it's a Nikon camera. And so it's a well-defined problem, and the labels are good and plenty, because there is a research community. There are some data sets publicly available that researchers actually have published that they're using to basically benchmark their models. And right now the industry, for instance, in the object detection, is actually also going in all kinds of directions. It's not only about accuracy or precision, it's all about also the size of the networks. Can you run this on smaller devices? The efficiency of the computation, the efficiency of training. Again, how can we push the boundary forward? I feel when we still speaking about this AI ops, like this is such an ominous term. Like we should define some problem. We should try to collaboratively come up with some data set, maybe a toy data set, maybe like let's build some toy application, then let's expose it to some random users with appropriate disclaimers, and then maybe collect this data and donate it for researchers to be able to mine and do something. Because I think otherwise, without this, we have no common standards. We have no way of comparing which models are performing better or worse. And again, coming back to what I think Matt wants to see, and you're saying, I don't think we'll reach situation in any time soon where there's like this one model that does everything. There's going to be different models, even maybe for different companies, different applications. The same way as for instance, we in cloud at Google, we offer the Vision API, where you can basically send an image and it will annotate what the image is about. But we also offer the sort of automatic service where you can also augment our data set with something that's relevant to you. Like our network is trained on sort of general images, but maybe if you're some kind of botanist and you would like to detect what kind of flowers this is, like our data set is not really well performing on that. So, but if you can give us your data set, we can maybe tune the model so that it better serve your use case. So again, I think we need to have some common data sets, and we need to build some technologies so that we can actually customize some of those models for specific environments.
Those are excellent points, and also pointers, I think, for researchers who will be listening to this to these panels. Thanks, Adam. Matt, anything you want to add on this?
I think the point about, if you think about an operating environment, if I'm really concerned with, say, mean time to recover against a critical incident, and I probably don't have many incidents to begin with. The ones I do are impactful. So few signals amongst all that data. I think being able to get some data sets that the researchers could use and figure out what that looks like becomes extremely important. And I think also, again, it's sort of this over what period of time. Because you can think within a given year, maybe if I'm only having one major incident a week that I care about, and that impacts the business. And I would argue that that's even a lot for depending on your business size. That's still not a lot of data points amidst all the log files. And then you've also got this challenge again within a heterogeneous IT operating environment where you've got many different sources. So you may say, well, just give me your log file, but log file is only going to tell part of the story. Because if I'm really concerned with is what is the impact to my business if there is, I don't know, slow performing application. And I think we've got some AI that can start to look at that with the, 4 golden signals, for example. There's other data sources that we need to go after. And how do I easily get a researcher access to them? Where, again, on some of my apps, I may have it in one tool in one format, another apps, I may have it in another tool in another format. And if the researchers have to spend all this time figuring out how to parse through log files or diagnostic data, I mean, that might be an area to dig into just of itself. How can I give you the log files and I don't need to tell you what you're looking at, but you tell me anything meaningful in those? Because I think when we were preparing for this, we had a little bit of a dialogue about that problem in particular. And again, if I bring someone new into my organization, I can get them up to speed pretty quickly on what sort of signals to look in those log files and not have to give them a whole lot of guidance. But I think that's where over a long extended period of time where maybe you're collecting this over years from many different companies and as Adam said, anonymizing the data so that it's protected, then you can maybe get to a point like you have with the image database to be able to train different networks on it.
Very well said. I want to, again, ask the audience if they want to submit any questions. You can type them in the chat or just pop in and ask. While we wait for that, I wanted to go back, Matt, to one thing you said before, which is the fact that many of the systems you deal with were really built like 10 years ago. And certainly most of the systems we have built never thought of AI or machine learning or even statistical analysis to be necessarily the consumers of, say, the logs that get produced or other types of signals. And I'm wondering do you feel that we should really, and whoever of you wants to answer this first, should we concentrate on making the applications themselves more amenable to AI management, so to speak? Or should we really try and crack the problem for our legacy systems and these very hybrid and heterogeneous systems that we have today?
I would say if I could get the applications to do anything that I wanted them to do, my life would be so much easier. So I would say, to put it bluntly, I think it's unrealistic that, again, the applications are going to optimize towards their business need. And the good thing is, I think within the past decade, with the advent of cloud computing, we've seen better standardization of application architectures and patterns that can be applied and toolkits coming from the open source community that directly support those patterns. But there's just so much out there that even if you were able to get applications that were built today going forward to be, call it AI friendly, that's not the stuff that I'm really worried about on a day-to-day basis. It's the stuff that I don't understand, where the person maybe retired last week and I'm like, oh my goodness, what am I going to do now if something goes wrong with that? Applications that are really concerning. And it takes, I think, machines and people going in there. And I know there's some tools now available that help you figure out, well, what's the business logic and all the source code that you can't understand. And I think that's more in my mind how we need to deal with the problem of, yes, we're going to see better applications developed in better ways that I think will help this, but it's all the other stuff that's not going away anytime soon that from a practical business perspective is what we really need to be able to get into and understand.
I'm probably going to say that we probably need both at some point, to some degree. Like I first of all, I will completely acknowledge that AI or machine learning models should meet the applications where they are, because some of them, as Matt said, like they're not going anywhere. Nobody's actually going to rewrite millions of code just so that it's a bit easier to manage. So the AI would have to, or the models will have to learn how to deal with what humans have. But at the same time, like we shouldn't also just throw our hands in the air. We should also come up with ways how to augment those applications, or the newer applications to be more amenable. But I actually don't think that the principles in how we build applications actually change that much in the context of AI. I think the basic principles is as similar as to automation. Like we need to have some observability into the applications, like have some signals being a logs or some kind of time series. And we also need to have some basically some control surfaces. Like if your only control surface is to SSH into a particular, I don't know, switch and type some commands into some text editor and then push it, it's going to be a bit harder to automate and for AI to interact with. If the system would have a clear API, then I think it's much easier. And on that note, and especially I think I would say one thing to be careful about AI system is that the model is trained on some function that it's trying to optimize. And in terms of the classification, it's a loss function. How far apart is it from labels? In terms of optimization, it will try to maybe improve the efficiency, the cost or latency of something. But we have to be very careful to precisely explain what we mean, because the model will exploit every single thing that is actually missing from this function. So maybe just to give you an example, it's super cheap and fast to serve errors to the users, but it's probably not what you actually want for your model to drive your system to. And you don't have to ask me how I know that.
Very good. Okay, we have no questions from the audience. Again, if anybody wants to ask a question, even live, feel free. At this point, I'd like to end on a positive note. And so I thought, in a very constructive way, again, given the audience for this panel, which is primarily researchers in this area, what guidance would you give them as to how to make meaningful progress? We've already talked about data. We talked about really taxonomizing the types of applications and really focusing on specific problems. There are other things I don't want to steal your thunder, so I'll leave it at that. Let's go, Adam, since you're unmuted, maybe we start with you. What guidance would you provide? Where do you think is the next low-hanging fruit, or maybe even the fundamental problem that we need to address?
It's a very broad question.
Feel free to refine it as you like.
I think one thing that we all would like to have better in the coming years, it will be to, and that might be relatively low-hanging fruit because we already have systems that are mostly good enough. It's the anomaly detection. This still requires maybe some amount of tweaking regarding sort of the amount of false positive or false negative that the system is willing to accept. That probably would be the relatively low-hanging fruit. But is this the area where the researchers should be going after? I don't know. I think it depends. Whether if they're going after the commercial success, then I would say they should look for the areas where there's actually the biggest value, because those systems are not going to be easy to implement, and this will require a lot of work. So for this to be commercially successful, this has to provide value, or maybe as Matt was saying, like it should tell us something that we don't know, or significantly reduce our operation costs, so that maybe we don't need so many junior engineers to looking at certain things. Academically wise, I would be very interested and very curious about, like, can we actually do at some point some root cause analysis? Like if we were to aggregate all the signals from all the monitoring data we might have, all the logs from the application level, from hardware level, and maybe with some additional assumption or help that the time is somewhat aligned between those machines, can we actually pinpoint where the problem is? I think this is an interesting and challenging problem, or basically try to detect what has caused the outage. But I'm not going to be. I don't think it's an easy problem, to the point where at multiple postmortems, sometimes it takes a weeks of experts' time to actually figure out what actually caused the issue. But at the same time, we need to accept that machine learning models are not necessarily a solution for 100% of the problems. If it solves 80% of the problems so that we can maybe reduce the staffing, or we can scale better, I think this is already good enough for the commercial success. So I would maybe on a positive note, I would say don't get discouraged if the model is not 100% accurate. I don't think this should be the bar for the models.
Yeah, I'll disagree with you on one of those points, Adam, because that root cause analysis to me is a little bit interesting, because what I can, and I think maybe it's less of a disagreement, more on specificity, because over the course of my career, now I see fewer and fewer things that can be incidents or outages, if you will, that can be traced to a single factor. And when we have the people go, it usually comes back human error. And the reason is that from my perspective, which is frustrating, it's like I didn't need to take a week to figure that out. But from my perspective, it's more the business applications with the architectures that we have and the resiliency and the software platforms has made it less of an issue if I have a single hardware failure. So knowing that in of itself isn't very useful if I'm concerned from a business resiliency perspective. I expect the hardware to fail. I expect the software to handle that. I've got multiple layers of resiliency built into that. But if I'm concerned with, okay, what hardware do I need to replace when on the floor of the data center, for those teams involved, it becomes a very different issue. And I think some of the root cause analysis could be useful for that. Back to the question, I mean, I would encourage folks, though, I think for my mind, there's really three dimensions. One is the data that we talked about, and is there an opportunity to get organizations that are interested in this to be able to anonymize their data so there's a good data set with which to work. And then I would almost say playing the long game of, could you train a model in the same way that you would train a junior engineer, so that 5 or 6 years from now they could do something useful and be a lot more general purpose than, say, the way that we're thinking about models today. And then I think going after a very specific problem, and the optimization problem that I see coming up more and more is, how do we optimize workload placement, or even how I'm modernizing my applications and my infrastructure from an environmental factor, and how am I having the greenest footprint possible, if you will, with my power utilization, my consumption, the hardware on those. And I think that's an interesting optimization problem that I think AI could be really useful for, is like, just tell me where I should put all my stuff. Because I think some organizations are still concerned about the dollars and cents, but over the past decade, 15 years, we've really started to optimize that, right? People made their careers on, I'm going to cut your core budget by X number of dollars in good. So it's kind of like you're squeezing a rock there. But the next thing is from the environmental efficiency perspective, and where do I put the workloads? Or do I even, now that I've got the capabilities with containers to move my workloads, maybe as the sun moves around, is there better opportunity, and network bandwidth has become a lot better in most regions of the world? Tell me where I should not just put my workloads, but where I should move them in order to optimize my environmental impact and for the greater good. And I think that could be very interesting and be a little bit green at the same time.
That is a great idea. Thank you, Matt. So I subscribe to that. Very good. I don't see questions in the chat. I guess last chance to ask a question to our experts. And if not, any parting thoughts, any final remarks?
I just say, hey, thanks. I love chatting with you on this topic, Fausto and Adam. It's always fun to hear the different thoughts. I think that there's immense potential out here. And again, just like in some other areas of research where the way to solve it is to narrow the focus so that we can kind of take it off piecemeal. I think that's really the way we need to start talking about it, aside from all the marketing literature that I get on a daily basis of how some new solution is AI ops enabled and sort of solving all my problems, because they don't. But you can solve a couple really specific problems for me, then let's chat. So I'm super excited about the potential and hopefully what all the people listening to this are going to come up with and work through over the next couple of years.
Fantastic. Adam?
I would say I'm also excited to observe towards the area in the coming years. I think I'm hopeful that we'll see a lot of progress, a lot of improvements. I don't think in any way this sort of affects my job security. I don't think I don't think the AI anytime is going to replace the engineers, although something that I probably mentioned, but I think the engineers using AI will probably replace the ones that don't, and we'll see this across all kinds of areas in engineering. I mean, even recently, I think OpenAI published a new model based on GPT that helps with the sort of writing code. So we'll see more and more sort of assistive applications, but we will still probably need humans to sort of string all those things together. But they're focusing on the right problems and solving them well. I think this will create a very successful endeavors for many people in the coming years.
Terrific. Well, I want to thank both of you, Adam and Matt. You have been great in engaging in this very fruitful discussion. I hope this was also useful to the people attending as well as to the many that will watch the recording. So thanks so much. Looking forward to working.
Have a fantastic day.
Thank you.
Bye-bye.
Thanks for joining us.